Hello, everyone. I hope you can all hear me and see me. We are ready to get started. Thank you for joining our session yesterday. We're very excited to be starting our session now. I'm going to give 1 minute for more people to join in, and then we'll be on our way. Um, this today, what we're trying to do is we're trying to stream everything on YouTube. This way, everyone will have access to the video recording after the session. You all should be able to get on YouTube, be able to watch what we're doing. So I'm going to paste the link. So if you're joining us on over here, we would recommend you to join the link on YouTube so that we can all be over there. This way you can connect with us, chat with us on YouTube. I have pasted the link for those who are on StreamYard. So without further ado, what I'll do is I will get started over here. All right. Can everybody see my screen? Once we can confirm you guys can see my screen, I'm going to go ahead get started on the other part. All right, awesome. So it's also always very important to know the technology is working. We're very excited for day two. Day two is going to be incredible. It's one of my favorite parts where I talk about search from what it used to be to what it is now. We're going to talk a little bit about RAG, and then we're going to talk a lot about agentic routers. So if you've never worked on agentic routers, you don't know what they are. This is the day. So just everyone, thank you everyone for joining back again. Welcome back. This is day two of when we talk about agent boot camps, and we cover a very important topic, which is which is search and retrieval. Which is search and retrieval on just search and retrieval for agents. And if you think about it, agentic ecosystems are one of the most important things and RAG within that, one of the important things when we drive and we build our tools. I have two links for you all. Link number one, if you have not joined our Discord community, please go ahead and join our Discord community. You will see the link on the left. Um, uh, if you see on the left, you will see you can join the Discord community. On the right, we have our GitHub that we discussed yesterday. The GitHub is a place where we have shared just about everything. We have built a very big course over there, so people can follow. I'm going to share overview of this. So this is where our GitHub is. I would love for you all to just follow this. We post a lot of different architectures and attend overviews. If you click here, this is almost an entire book that we have created with chapters. These chapters are important to explain what's happening. How do we go from ChatGPT to n8n, and how do we learn about them? All of this information is available over here. Some of the topics that we discussed yesterday, they're all over here. And then we go deeper into how agents are working, how to get started with Lovable, how to get started with n8n. This is the sales agent that we showed you yesterday. This is one of the Perplexity clones that we showed in the class, which is Lisa. So all of that information that you need to learn and to grow about agents or automation agents, it's all available over here for you all. The reason is I would love for you to learn this, grow from this. These are important topics that will help you grow and become better. All right, and just to reiterate, if you haven't joined the Discord community, on the left QR code, we have the link to Discord, and on the right we have our GitHub repo where you can follow through all the different things of what we are teaching. Again, this is all to help you to work with you and to showcase all our learnings and making them available to everyone. For those who are joining for the first time, I want to tell you about myself. My name is Hamza. I'm founder and CEO of a startup with the name of Traversal.ai. I was previously at Google and Walmart Labs. I have quite a few experience in machine learning, and I am an adjunct professor, Stanford Continuing Studies, and UCLA, and a bunch of other universities. I'm joined by Gabriella. She will not be taking today's session, but I've been she has helped build this course. What we have over here, she's extremely popular. She's very well known in the world in what she did. She was previously a director of AI at Microsoft. This is the team that has worked very hard to put everything together. They are behind the scenes. Believe me, I cannot do anything without these people. So these folks have done a really really good job on putting things together, and they've done great job in making things available to everyone. So a big thank you so much everyone who has been behind the scenes and putting it together. So I see a few comments that we would like to see the community or the Discord community or the GitHub. So these are the links. This is the Discord community, and then the one over here. And if you go to the YouTube link also, in the YouTube link, in the description, we also have the Discord link and the link to the and the link to our GitHub. And you can also follow, like, since this is now on YouTube, we're streaming live on YouTube. You should be able to access that information. All right, moving forward. All right, recap. We have been teaching thousands of students across many organizations. Our idea is we want to democratize AI in a way that you actually understand and not get behind the hype only, but you actually build things. I have myself been teaching across multiple universities, multiple ecosystems, and it sort of helps drive this drive this work. I know that some of you, I have worked with you before, so if in the chat, I would love some of you to tell me where we met for the first time. Some of you have taken a course with me from Stanford, some of you took a course from me from UCLA, some of you were on Maven. So where I would love to hear from you all where we connected before, where we connected before, and which course did you take with me. There are I've I've been teaching for the past 5 years, and just this is the first time that we decided that we wanted to make it all available. What we are doing, make it available to everyone, and sort of do live streaming, so that you can ask questions. You can ask questions live, and we can learn from each other. I know those I see few comments on Maven. So guys, thank you so much for joining in. All right. So again, we will be live streaming this entire this thing on YouTube. You can start it. You can subscribe to it. This way, what you can do is whenever you want to come back to watch it, you should be able to do so. One of the great things about live streaming is that we can actually keep an I can try to answer questions for you all during this session. um, that's the whole idea. We can always do a video recording and just launch it online, but we want to sort of hear from you during the session, and if there's something that we can help answer. So use your chat to ask questions, use your chat to discuss some challenges. Our job is to make sure that we can help answer as many things as possible. So we will be our focus is to make sure that you take advantage of this live session. You take advantage and you learn as much as possible by asking live questions. So what we have learned so far from yesterday, we talked about agents, which are software that use data and tools to achieve goals. Why we want to use agents, how we use agents. We move from chat to workflows that create real output. There were 3 levels of agents that we discussed. We built level 1 automation, which is LLM with tools. Next week, we'll talk about React. So guys, I'm very excited about React. React is amazing when it comes to life. And then we'll talk about A2A, which is GCP. So today and the next 2 days are going to be a little code heavy. We have done it by design. The reason is if you don't do something code heavy, if you don't do code heavy stuff, you're not really building. My job is to give you the entire code, give you all the entire code to work with, but you should be able to understand what's happening behind the code. And the best thing is, all the code that we'll give you will not have LangChain or Llama index in it. There will be no frameworks. The entire code, the entire code that you will see is from scratch and from ground up. The reason is simple. Uh, the frameworks keep changing, the ideas behind them keeps changing. There's very little abstraction that they offer. So what we've tried to do is that all the code that we will share with you. So this is code number one that we will share with you today. This entire code is free from LangChain, free from Llama Index. It literally builds everything from scratch. Be it chunking. If you guys know what chunking is, this is entirely built from scratch. Chunking, and the whole embedding architecture, everything with quadrant connectivity. None of that uses any kind of framework. Again, it will take you a little time to understand this code, which is fine. But once you understand, you will be able to use it and sort of grow from this. So my idea is, you need to be able to run this code yourself. You should be able to understand what's happening behind the scenes over here. That's what we try to push actively in our courses. In my every I run a startup. We've been running it for 2 3 years. And one of the things we do is that we want to teach you how to do something, look under the hood, rather than just picking up something at an abstract level. And it's fine, you can pick something at an abstract level, that's absolutely fine. But then you don't understand what's happening. So when something breaks, you don't know what's breaking it. And that's one of the worst things that we can do with AI, is that we vibe code our way into things. And when we are vibe coding things, we don't end up learning anything. We're just making something. So I'm actually the opposite of that. We try to say, okay, you know what, we're going to build something which is sustainable. We're going to build something which actually works, and we're going to do these things so that people can take advantage and build something better out of it themselves. So whatever you want to tinker, you get to tinker. Today's learning outcomes are very good. We're going to talk about search in different formats. We're going to talk a little bit about keyword search. Then we're going to go into semantic search. We're going to go into retrieval augmented generations. Those of you who have not worked with it, you guys need to level up or learn about it as soon as possible, because this is one of the most important topics in the past 2 years. Then we'll talk about what are the limitations of naive RAG, and then after that we'll talk about enterprise RAG, and then finally we'll talk about something very cool, which is agentic RAG router. So I would love for you to sort of stick around till the end, because the last 30 minutes we're going to talk about routers and how do we build better sustainable agentic RAG in our ecosystem. Because once we build those systems, our retrieval systems become really good. And if somebody says RAG is dead because the LLM context length is too big, I just want you to understand this, that, and people say, oh, I can fit 3 books, I can fit 4 books in my entire context. I just want you to know that search is not made for 3 books or 4 books. Search RAG is built for millions of documents. So the mode of your entirety of what you build is on how you build your routers, your agentic ecosystem, and how you build better search. So if anybody imagines that, oh, we're going to build something which is, we don't need to use RAG because the context length is so long, that is something that shows lack of knowledge on that. Because your entirety of your moat of what you build is based on search capabilities. All right. So if you're building search in your company, if you're doing something interesting on search, tell us about it, and I'll try to sort of engage with you during the conversation on how you can use search, or what were you doing with search in your company, because search and RAG go hand in hand. But if somebody were to ask me how important search is in a RAG, I would say 18 to 90% of your entire ecosystem should be reliant on how good your search is, versus how good your LLM is, because the LLMs are nothing but commodities. and to be honest, one of the most expensive things when you're building your when you're building your ecosystem. So I would love to know, how are you guys building search in your company? What are some of the challenges that you're seeing? And what kind of ecosystems are you thinking? What are you thinking about? Open source LLMs? You're thinking of closed source LLMs? We'll discuss all of those in our sessions. All right. So what is search? What is basic search? Search is fundamentally about finding a needle in a haystack. Search is about, hey, I'm looking for a place to go. I'm looking for something, and search sort of delivers you. Now, this is a very old definition, and this is what we all grew up on. We haven't known of a world before Google. We've always used some kind of search engine, but search engines are difficult to build, not because not because of the fact that search architecture is difficult, but because people have so many different intentions, people have so many different requirements, and no two people have the same way of what they need. So search is very complicated, very complicated. And those of you who have worked, I've worked on two search engines in my life, and as a company, I worked at Walmart.com search, which was daily 10 million daily active users. And then I worked at a small company, you might have heard of it, called Google. In Google, we basically worked on building an ecosystem where we understood users, the billions of queries per per minute. So search is complicated. Sometimes we search for something and we don't get the right results. That's because understanding user intent is one of the biggest challenges when it comes to working with search. And one of the things that we've seen is that in the past years is the size of search queries is increasing. Search is no more just keyword based. In fact, if you go to a website which only has keyword now, you basically you will basically identify, and you'll be like, okay, this company does not have good search. So search is a fundamental requirement of a company's website that should work so well that it will take you to where your customer needs to be. So I would really want you to think hard on this, that search is a fundamental ecosystem of e-commerce, and business is growing in double digits online. So when we have good search, and I know it's very basic, like it's like a dull moment. It's like, of course search needs to be better. What do you mean by search? But building search is difficult. I'm not saying you should not have search, but what I'm trying to say is search is difficult to build in the first place. It really requires energy from you to build it right way, and sort of requires you to design those architectures correctly. So search is evolving, and one of the things that we're seeing is we are now asking longer queries. We're asking longer questions. So previously, when you would do keyword search, and we'll talk about some of the highlights on keyword search, but you would just say Nike blue T-shirt or Nike blue T-shirt golf. Here we can actually type, and if you don't like to type, you can actually add voice. So the thing is, the greatest thing about generative AI search or semantic search is it's allowing you to build a search in which you can build conversations, hence the word conversational search. So previously, when you would try to go to shop at a store, you would not use keywords. You wouldn't say Nike blue shirt. You would actually say, or you would actually try to introduce yourself by saying that, hey, I am looking for this kind of product. I would like a Nike blue t-shirt for golf. I want it to be comfortable, fit, moisture wicking fabric, and I want size medium, and I'm hoping it's like not more than $50 or not more than $100. So what we're essentially doing over here is that we're expressing our intent to the user. We're expressing our intent to the person that we're going and asking for help is, can you please identify this? And that part of search is conversational search, which was very difficult to build with keyword based search. However, now we can design systems that can break down our query. So this entire query can be broken down into smaller queries. These smaller queries can do individual search on our ecosystem. We can search individual tools on our ecosystem or individual searches, and using those individual searches, you can actually find really good answer or the right t-shirt which you're looking for. So I just want to say that in conversational search, what happens or what potentially happens is that you take a complex query like this, which has many, many parts to it. You can break it down into smaller queries using an LLM or agentic ecosystem and do individual searches. This way, you are basically dividing and conquering the search space, and you basically take a cumulative or the best features from each one of those queries to eventually find to combine into results. This is how we basically use, or we're going to use semantic search. And if you sort of look in today's world, there are two kinds of searches that exist. This is traditional. One of them is traditional keyword searches, which is probably 99.9% of the world. So 99.9% of the world websites have traditional keyword search where you just put in keywords. However, I want to say 99.9% search is keyword, but Google and other search engines have introduced semantic search, query intent, context, and semantics into their search. So not all search is keyword now, but a lot of companies, individual companies, still have keyword-based search built into their ecosystem, which is built on something which we call as TF-IDF and BM25. Now, some of you might not be aware of TF-IDF and BM25, but BM25, TF-IDF are one of the characteristic known search engines that have been built for keyword-based search, and they sort of work behind the scenes so that you can use them. On the other hand, semantic search basically is something that we've been working on, which basically understands the user content. Because when we talk about keyword search, we're only identifying important keywords, and based on those keywords, you're able to build or you're able to design what that search would be, or what kind of results you get. But it's very important to identify that every time you build that search, every time you design that search, it will focus on keyword based results. It will not be focused on results which understand the intent. They only understand what you're trying to build, and sorry, they not only understand what you're trying to build and sort of work with that purpose. They actually are not responsible for building something which which basically explains that if you say golf t-shirt, it will try to only look for golf. But if you say sports t-shirt, it might give you golf, it might give you something else. But so this is sort of the main differentiation factors when we think about these search engines, is that they're built in a different way, and they don't understand the intent. They're only looking for keywords. Now, most of you know this. I don't think I need to go in a lot of detail about it, but I just wanted to highlight that this is what 99.9% of the world runs on. Semantic search, on the other hand, focuses on meaning and not just the word. So it tries to understand what you're saying and try to find the similarity that is closest to what you would like to use behind the scenes for that purpose. Um, um, uh, for that. All right. And if we talk about semantic search itself, there's a prompt, there's a query, there's a semantic search, there's a relevant information extraction, which basically finds the right chunks of data. Then we put it together into something which we build into RAG. So what I would like to do now is, instead of going just to theory, instead of going just to theory, what I'll do is I'll do something better. I want to show you code. And I know some of you find it a little cringe to work with code. I would love to show you this code because you need to see live examples. You need to see those examples that sort of explain on what's going on behind the scenes, how you can work with them, and sort of see what that means to work with those tools. So we have a bunch of different examples that we have, but and we'll share these code bases with you. Don't worry about these code, what they are and how they work. But we will share these code bases with you. You can evaluate them. I'll start with a very basic one. This code over here. Can everybody see the code base? I just want someone to say yes. I know you will. There's a bit of a lag. Yeah. All right. So I'm gonna run very fast through the code because I just want to show you a few basic things. So previously, what we used to do is that we used to build search based on keyword based. All right. And keyword based, basically what it did is that it would just build something for you from very basic stuff, and you would go. So the essential terms, like there's BM25, there are others, and if you know what BM25 is, you're already good in the conversation. You don't need to learn from me. But one of the things that one of the ways that we used to teach search, keyword based search, was something called TF-IDF. And TF-IDF sort of stands for term frequency inverse document frequency. I know it's a big word, but we have explained it. It looks at how often a keyword was mentioned, and it would look at words which were important, and it would take out words which were, like which did not have any meaning, like the word the or in or how. It would remove those words and would only keep the words which were really, really important. So an article about football match might have high TDF or TF-IDF scores for word like goal, referee, and player names. An article about cooking might have high IDF scores for recipe, ingredients, and specific dishes. And believe me, if you start understanding how this keyword-based search works for you, you will be able to see things come to life very fast. You should be able to see what's happening behind the scenes. So what I'll do is I will make this code available. Don't worry about the code being available or not. But what I would love for you to do is just understand what's happening behind the scenes. So here we have seven documents or seven phrases that we would like to search. Okay. Here I have a query: animal that chases mouse. All right. And then when you sort of look at the results, every single score is 0 over here. Again, I just want to show you something. We have these documents, sort of we these phrases within our keyword. We have the cat is playing in the garden. A dog and cat are good pets. Cats love to chase mice. I don't know if it's true or not. I mean, we have been lied about Tom and Jerry all our life, but at least the idea is there. Machine learning is based on algorithms. Deep learning uses neural networks. Recurrent networks have connections. The cost of this shirt is $15. So over here, when we use keyword search, if I use words which are not mentioned, so animal that chases mouse should be related to cats love to chase mice. However, because of those exact words not appearing in our search, what you will see is that every score is 0. Which is very important to identify is every time you work with keyword search, every time you work um, every time when you use this, every time you use this method, you need to have the keyword mentioned. You need to sort of have this question mentioned, because it's just very difficult to keep track of what's happening. Sorry, it's just very difficult to keep track. Like if you don't have the keyword mentioned, it will not give you an answer. So, but for instance, if I say, and I show you the results, it will still not work because I use the word cats over here. So you see, these things are so sensitive. Now, there are other things that you can do. You can clean up the text. You can go to the roots of the word. I'm not getting here into the very depths of how do we the lemmatization and all those techniques. Some of you, I really want to know that if that you guys know what lemmatization is. These were really good techniques that we used to use in back in the day. Um, uh, that sort of gives us the background on these things. So what lemmatization does is that it gets your word to the root word that it used to exist. So here, if I just change the word to cat, now you will see is you're able to get an information, you're able to get an answer, which is very close. But here's the fun part. Here's the fun part. My query was cat that chases mouse. I would have loved to see this thing come up, but because it is even sensitive to it is even case sensitive. Of course, when you actually build this in ecosystem, you make everything lowercase, you do stemming, you do lemmatization, we do all those things. So that's a standard of doing search. But I just want to preface this to you that in keyword search, if that exact form of word is not defined, if that exact form of word is not defined or explained, you will see responses. You will see responses which just don't add up. And this has been the biggest problem. This has been the problem about how we see LLMs. Sorry, how we see search being so frustrating with keywords. They don't understand what we are trying to say. What we are trying to do is only picking up exact keywords that we have mentioned, and that's why we used to make our search very keyword based. All right. Then came semantic search. And semantic search said, okay, you know what? We're going to look at what you're thinking, what you're trying to say, and trying to find something very similar to that. And that's what we sort of try to do and build over here to showcase some of the things over there. So I'm going to use a very prehistoric model. If you have worked on mini LLM v6, you are the OG of encoder models. I don't know if you guys have worked on this. If anyone has worked on mini LLM v6, mini L6 v2, please put your name out there. I'm gonna hats off to you if you're the OG encoder model architect. I mean, of course, now there's so many encoder models, but I want to show you how the OG stuff used to work. So what happens over here is that you have something like a cat is playing in the ground, the same exact documents or phrases that we had in the previous one. Here, what we're doing is that we are running an encoder model. The encoder model basically, downloads our information, downloads the model, and sort of runs behind the scenes. You can see the model of how it works. One of the reasons I use this is this is it's a very lightweight model that can be used. We then use embedding model. We create our embeddings. Once we've created our embeddings, they're all visible over here. Now, some of you might have worked with embeddings before. If you haven't worked on embeddings, we can share some resources about how embeddings work. But essentially, what we're trying to do is that we're trying to map this information into a vector in vector format like this over here. And what we're trying to do is we're trying to find out how similar our query is to what our questions is. I've written, again, I've tried to write as much code myself from scratch as possible. The reason is simple. We want to be able to showcase you how it all works and how it all comes to life. So over here, when I wrote, and actually just make it simple. So when I write a query, it basically tries to find out which document is most similar. So when I say an animal that chases a mouse, here it will say cats love to chase mice. So what it did is that it did not look at what exact keywords, um, what exact keywords were used. It only looked at, it only looked at, it only looked at the context of what you were saying. So it compared using cosine similarity. So here, if you know what cosine similarity is, it's right over here. It used cosine similarity to compare documents which were very similar to each other, not exact keywords. When I say similar to each other, it's contextually looking at, it only looks at the embeddings of how we have mapped them. So this basically, no keywords mentioned, no exact reference to the documents over here. However, so the documents are right here for you to see. Here, there's no mouse, there's mice, but there's no mouse, and there is no animal, there's no mention of an animal. So it sort of looked into the information and said, you know what? I was able to find something which is very similar, and this is the most similar document for me. Cats love to chase mice. So again, I've tried to build a very simple example for you all to sort of look into what we're trying to explain. I'll use another example over here. So I just say generative, or articles. So what it did is that when I said articles on generative AI, it found a document which says machine learning is based on algorithms. So it's basically what it's trying to do. It said, I did not find a lot of articles that you were looking for, but what it did is that if you look closely over here, it gave a high score to at least three very relevant documents: machine learning, deep learning, recurrent running. So it basically looks at similarity of the context of you, what you're looking for, and it sort of builds based on that. I'm going to try one more. It says GANs are important. And if you see, GANs are important. I didn't even refer to any kind of deep learning, but it understood that when you talk about GANs, you're talking about deep learning. That's what it's useful for. And if you think about it, because these models are so lightweight, and they do such a good job in coming to life, we build and scale this to millions of documents. This ecosystem can allow us to build large scale systems without us even thinking about it, like how difficult it is. And that's the greatest part about these tools. Semantic search, one of the biggest, most powerful thing about semantic search is that it can be scaled very fast. It can work on millions of documents. Storage is relatively very cheap with them, and these models do not require GPUs to run. So just want to rephrase, embedding models, encoder models are relatively very cheap to run, which means that you do not need massive GPUs in your ecosystem, and you can host this entirely on your local system. Now, this is not without its challenges, and I really want to highlight that. If you think about it, this has one fundamental issue. there's one fundamental issue that exists in these LLMs, is that when you use an embedding model, it does not understand the relationship between numbers. So for instance, if I write the cost of this shirt is 10.99, you will get an answer which is 0.7621, which means it's closest to the document of shirt. However, if I do 19, so remember it was 0.7621, it went higher. So you see, it got closer to it. So it was able to identify that 15 and 19 are better. Now, if you keep changing the values, you will see that 150 becomes a better value because it is able to see it the way it breaks your numbers. It does not look at your entire number in one go. It breaks your number. So when you have numbers in your ecosystem, so if I wrote 1500, right, my relative score is my similarity score is 0.90665, right? It's a great score. However, the semantic meaning of the query is too far. So remember, it was 0.9. However, semantically, 300 should be closer to 15. And yet, when I went from a pricing of 1500 to 300, the value actually decreased. So essentially, what I'm trying to say is when you work with numbers, on semantic search, it errors out. It creates problems for you. It basically generates response which are not most relevant to you, because keyword based search, semantic search does not do great job when it's embedding too. So I'll repeat what I'm saying again. If I say similarity to 1500, you get a much higher score because it had the letter 15 in it also. So the way it embedded is that it broke it down to 15 and 00, so it compared to 15. But if I say 37, the score actually goes further down. And if I say 88, the score goes down even further. So the mapping that I'm trying to explain to you over here is that when we work with numbers, semantic search does not do a great job. It really creates a problem for you as you work with this and sort of unable to grow into that ecosystem. One last thing is, when you have millions of documents, we have built systems now that look for document update. So you can go to the exact document, you can go to that exact chunk or chunks of documents which are created, and you can use an ecosystem, you can use the update theme to sort of update that life. So what I'll do now is I'll sort of try to go through some questions that people have asked during this session and try to answer them, as we go. So someone said you can update a specific embedding based on document ID. So yes, that's I think someone answered that you can identify based on the update. So what I would love for you to do is I'm going to wait for like 30 seconds, and if you have questions, I would like to answer those questions. For you, which embedding techniques is used when underlying data is changing? The embedding does not change. Your embedding does not change. Your architecture of updating your documents change. So I want to say that when you are changing your data, have a you have to maintain a log ecosystem. You have to maintain a log ecosystem that allows you to be able to evaluate the embedding of that exact document as you go. There's another question: how do we search if they are numbers? That is a great question. what happens is, when you are trying to do, when you have numbers, you basically use an LLM router or use something behind the scenes to rewrite those queries or hybrid search of some certain forms. We have written a very, very good paper on that. I'm going to share this paper with you all. I'm going to share my screen first. This is the paper that we recently, I mean, it's been a while that we published it, but this paper looks into that exact problem. Because what we found out is that when somebody asks a question, it's a mix of numbers, brands, and different things. And in order to curb that, what we recommended people is to sort of use a query decomposition principle. The query decomposition principle allows you to break your query into semantic embeddings and keyword extraction through an LLM. The LLM uses that, and using that LLM, you can sort of break out the ecosystem that sort of helps you design that. So we actually tested this ecosystem for e-commerce specifically, and we found out that the performance of these LLMs is at least twice better to semantic search. So it was 2.2x better over keyword search and 2.16x better over semantic search. So we have already published this paper. We'd love to, if somebody wants to read, you can we can share the link also. But this is when you have numbers, you have to use these tools to sort of answer that. There's a question. Could you also share best practices on managing context for a system with multiple use cases? What should the top K be set to it? What president should recommend other approaches? So basically, what happens is you have to look at what we usually do is we use something which is called RBAC, and I will sort of talk about RBAC is role-based access control, and we'll get into it in a minute over here. That RBAC is one of the cornerstones of when we're talking about multiple contexts, when we're talking about multiple things, and then eventually we need to build something which is an agentic router that sort of addresses that. So I'm going to take one or two more questions over here, and let me see if this is the link to the paper. Let me know if you guys can see it. The moderator in those session, can you please share the link on YouTube also? Are you guys able to see the link that I share here on YouTube? If not, we'll make sure that they're also available on YouTube. The idea is that you can read those blogs over there. So one of the things, I think Theo, you said currently developing a RAG system that has thousands or millions of documents. One issue is that I'm having is managing the context, as some systems may sometimes require that we fetch hundreds of documents. That is what we're going to talk about as a challenge for naive RAG. That is something that you should sort of think about how you design your ecosystems, or how can you design your ecosystem to bring these things to life. All right, so you can sort of follow through that as we discuss. So here, as we go through RAG, and just to recap, just to finish up on this, is once you have built search, all you need to do is wrap your results or wrap your responses into, I'm just going to show you guys real fast. You wrap your answer into a prompt, and it analyzes the response, and then it generates an output. Here, what we've done is that we've created an example of a search result for a hotel. So we built a search. There's another document where we built a search, but there's a document that says, hotel near Louvre with great food nearby. We saw that these were the results that came out. So we sort of wanted to show that how the prompt works. So here you will be able to see that we're using a RAG tool that sort of generates a response. Now, most people stick to this part. They just embed a document, they store it in a vector database, they build some kind of search on top of it, and they call it a day. That is what we call, my friends, a naive RAG. Naive RAG is where you have your documents, you generate chunks, you vectorize the chunks, you store embeddings with the documents. And then when somebody asks a question, you basically say, okay, you know what, I'm going to vectorize my question. I'm going to find the most relevant chunks. I'm going to use get those chunks over here and put them all together in LLM to generate a response, right? So this is one of the most interesting ways of, or to be honest, there are people have been working on this for the longest time. And believe me, when we go and talk to larger companies, a lot of LLMs or a lot of RAG tools with thousands of documents have been built on that, which is pretty interesting to think about. That these tools have been built for a long time, or they've been around, but this is what our basic knowledge of these things are. And this creates a lot of problems. They struggle to summarize because you fetch hundreds of documents. It is not built for summarization. You can't compare two answers. You can't say compare a to a, or or compare a to b or something like that. You can't compare those. You don't have memory, so you only can pass implicit information. It cannot derive an information. Lastly, there's no memory. So if you're trying to ask a question, what will happen is that it will remember the first question, but as soon as you ask a question on top of that, it just forgets. So if you have built a RAG tool before, these are some of the basic things that we see in naive RAG. So sort of take center stage on what we are building. And while I don't have the time to build and design an entire enterprise architecture for you, but these are some of the things that are very prevalent. And we start with the most important thing. I have tons of data in my ecosystem. How do I build something which does not push me, or which does not prevent me from going crazy? One more important thing is, in RAG, everybody has access to the same documents. In RAG, everyone has access. In naive RAG, everyone has access to the same documents. This is something which we commonly see. This is something that we commonly see in our ecosystem, is people are basically just building something, and them trying to make it available to everyone. This is the stupidest thing that happens in RAG. And that led to something being generated, which is called role-based access control. Role-based access control means is that we determine who should have access to what documents based on who they are and how the documents have been shared. Most often, we don't know, when we went and started working with companies, most documents in people's organization, they're in a folder. They don't know the policy. Like, they might know the policy that I'm not supposed to share, but in their mind, I'm not sharing it with anybody if nobody has the link to that document. That is what changes when you use RAG, is because these documents are then available to everyone in a vector database. And that is something which really, really becomes a tough job when you're working with those kind of tools, right? So we want to basically able to fix them and be able to answer them. The answer to these things is an enterprise RAG ecosystem, which has multiple roles to it. There is an input guardrail, there is query rewriting, there is huge storage, and there on top of it, there is observability that exists. Now, this is easier said than done, and many companies struggle to put it all together. A lot of tools that you use today are not built like this. This is what larger companies charge you an arm and a leg and a kidney for. So we will address one portion of this part today. We'll talk about how to build routers for better retrieval system. Before I go on, I'm going to take a few more questions. My team has been pinging me that people have been asking questions. So one of the star question is, in this case, so the chunking. So somebody said, are there best practices for chunking according to business domain? Yes. So chunking basically plays a very, very, very important role. We can talk about many, we can talk over days on what chunking is, but what I would suggest people to do is think about chunking as There, one of the things that we recommend is, at minimum, you should use recursive chunking. If you don't use recursive chunking, you should use semantic chunking. Semantic chunking plays a really, really good role on trying to generate really good results for you. And most important is evaluation techniques. Those are very, very important as you build these tools. Umesh, you said naive RAG works best for numbers. Naive RAG doesn't work best with numbers. You have to build hybrid search for that, in order to build that. I think Uday has a question. My team is also pasting these questions. What about data governance while working on these projects, all stages? Please share some insight on stakeholders. So basically, what we try to do, is we sit with the company to hire to create an evaluation data set. The evaluation data set is the most important thing on what kind of questions people might be asking or they would ask. This enables us to build that design based on that, because data governance means basically, how do you share your data, what kind of data do you share, what kind of embedding architecture, what kind of search engine is based on. Is it an entire company data that you're sharing? Is it one small company, like a one portion of the company data which you're sharing? Do people have different levels of access? Those are the questions that we need to have. We need to ask people in our. We need to ask people when when we are building these ecosystems, for that purpose. That helps us identify them. Um, how to decide which search is best for enterprise data. I think it always ends up being some kind of hybrid search. It can never be one kind of search, for that purpose. What is the core concept? Semantic search is used in background. If TF, so TF-IDF, Mohammed Hassan, to your question, is keyword based search, which looks at the overall answer based on that. However, cosine similarity is embedding architecture, which basically compares the context of two different things using in encoder models. If you have not read about encoder models basically try to understand what the sentence is and then compare it to other documents to look at the relative closeness of those documents. All right, I'm going to move on to explaining this a little bit detail. So as I said, you need to have enterprise RAG built so that enterprise RAG can be used to improve your ecosystem. There are many benefits. It improves your accuracy, it improves your retrieval, and enhances query handling. It do really well with large data sets, and you can get better results. And this is where we sort of start to introduce agents, where usually agents, you're talking about automations or React agents, but here you can have agents that can actually route your queries or rewrite the query that you're asking in the first place so that you can get better results. Agents help you identify that. And if you think about it, this is a very famous, I think, Llama index or LangChain slide, which basically talks about different ecosystems. These are some of these are what we're going to discuss today. We're going to talk about routing and tool use over here. What this one does is that it basically allows you to sort of use these tools to build better ecosystems. React is what we will do on day 3, and then dynamic planning and execution with React we'll talk about in A2A. So what is routing? Routing is when you basically have huge document sets, and the first thing you do is that you start partitioning your data. So one of the things that I tell people, I try to give them, similarity. The similarity of life is that when you think about routing, or when you think about large documents in your home, you're not considering documents in your home. You are not talking about documents in your home, which are basically, you don't put all your documents in one place, or at least I hope you don't. Or if you even keep your documents all in one place, you partition them. You basically keep them in different groups. This is the same concept that you need to apply when you think about architectures for RAG. You basically divide and conquer. So the first part is you route. What routing does is that when you, based on the query that you're seeing, you route the request to the particular group of people. You try to fixate yourself on staying away. You try to basically route the query based on the request of the user, and it basically gives you the capability to sort of use this different rack. Krish has a question: does n support routing? Yes, you can build routing within n also. So yesterday when we were building Lisa, there's another component to it. You can use RAG and internet search and other tools all at the same time. Those things are available when you do routing, even in n. And then the second part is one-shot query planning, which is basically it breaks down the entire query into smaller subqueries, and each subquery can be executed independently with other tools to sort of generate an answer. And finally, uh, sorry, and then so the idea is basically you use one-shot query planning, and you can use routing to sort of build your tools. Now, what I would like to do is I would like to show you a bunch of code over here. This is going to be a very extensive code, and we'll try to run it as much as possible. So this code is a very interesting code. What it does is that it has multiple components to it. It has internet search, and it has two databases in it. So as I run through this code, I'll give you guys an example. Here, what we have done is we have uploaded three different databases, so to speak. We have one vector database, which is OpenAI query about OpenAI query documents and agents. Then there is a 10K document query ecosystem. So if you don't know what 10K is, 10K are financial data which is released by companies. So these are very large documents. And the third thing is internet search. All of these three things are embedded within the search tool that we are building over here, which has three different ecosystems rather than one ecosystem which we are used to. In naive RAG, you always have one vector database. You always go to that vector database to try to generate a response. Here you use a router. The router basically allows you to route your request to a different vector database or an engine, internet query engine, to generate your response. And what it does is that it allows you to dynamically switch between tools, handle different types of user questions, avoid wasting resources on unnecessary steps. So this is a very important part of this, as we grow into our ecosystem, this is a very important part that we discuss with our users. Is building a router based system is very important, so that you can build that, um, um, so that we can sort of go from there in order to design that. All right, so let's just do one quick thing. As we go through this code, I'll show you more. So here I've run this part. I'm going to set up OpenAI. And here in the routers based system, what we do is that we write a prompt. Basically, we say, as a professional query router, your objective is to correctly classify user input in one of these categories. So one is if the person is asking about agents. So we've basically we've built three different tools. We have an OpenAI query vector database that we have created. We have a 10K vector database that we have created. And then we have internet search, which you also saw in yesterday's. So we create a router tool, and through few shot prompting, you explain to the LLM router that this is how I want you to respond. So when I say what is the revenue of Uber in 2021, it should understand that this should be referred to a 10K query. This question should be routed to a 10K query to answer the question. And then if I ask what is an AI agent, it will basically say, oh, because this kind of information exists in OpenAI query data set, I'm going to go to the OpenAI query vector database to answer the question. So these things sort of play a major role. These things play major role in sort of developing this and trying to build these things as we go. So again, I know there is limited time in what we can cover, but I really like, once you guys have access to this code, I would really like you to go through this in detail. What we do is that we have two sources of data. We have two vector database. We have a 10K database. We have an OpenAI official document vector database, and then we use internet search at the same time. Here we have already created a vector database, so you don't have to create that vector database yourself. All you need to do is keep running the data. We have an embedding model, which is the nomic embedding model, which is my favorite one, which I use now. And then as we go through, we build a RAG ecosystem, which basically says that when you get an answer, this is how you should respond. But what I would like to do is I would like to show you what the results look like. So here, what we have done is where we have a router, we have built a router model, which will basically route user requests to the particular group. We have a RAG, which is basically any other RAG. It does not know what routing did. All it's looking at is the request that people sent. It's looking at the request that people sent and uses those requests to sort of just generate a response. So when somebody asks a question, and hopefully this should work, but when somebody asks a question, what was Uber's revenue in 2021? It understood that it should go to a 10K document query. And using that information of 10K document, it retrieved from the vector database of 10K documents. So there are many ways. There are many ways that you can partition your data. I know. I want you to know this, that it comes down on how your product team or your management team decides, or what is the best architecture. So you could have finance team have separate documents. You can have marketing teams have separate documents. You can have HR have separate documents, and you can vectorize them and store them in different vector databases. Similarly, as you have databases in your company, you don't keep all your data in one database. You have many databases. Within those databases, there are many tables. So here you basically build logical breakdown. You break down these logical databases, and you sort of route the LLM towards them. So instead of looking at all the documents, I know somebody wrote, when we have millions of documents, how can we build better search? You can build better search by reducing the space of search you have. So you can reduce the amount of search that you do in the first place. So let's say I have a ton of documents in all my ecosystem. But instead of going through every single document, what it did is that it said, I'm only going to look at that particular partition of your data. And using that particular partition of the internet data or the data, it basically used it. Now, this is one interesting thing is when I ask a question, what was Lyft revenue in 2024? It hallucinated. It basically went to the internet query. And this is the thing that also is a challenge within router-based systems, is that you rely on an LLM. You rely on an LLM to generate a response for you. Okay, I want to rephrase that. You rely on an LLM to generate a response. However, the fallback should be that you have a tool that is doing the right job for you, that sort of enables you to use this tool behind the scenes to build an output. So here we used internet query to do the internet search. However, it should have gone to the 10K documents. Then we ask a different question. It says, list me down new LLMs in 2025. It said, this answer does not exist anywhere, so I'm going to use the internet search to generate a response, and this sort of generated responses for you based on that. Finally, then we ask a question, how to work with chat completions. It said, okay, I think I know this question should exist over in OpenAI. So it went correctly to OpenAI. So I want you guys to remember this. It went to OpenAI, but it could not find the answer in OpenAI. So there are two big challenges when we use routers. Routers, number one, can hallucinate on the tools you go to. And routers, even if they don't hallucinate, sometimes the answer does not exist in the place you're looking for, even if it's going to the right place. So you need to have a fallback. And that's what React agents do. So what I'm trying to set this up, what I'm trying to set this up on the conversation is, when you think about React agents, those are the agents which sort of take center stage, because when you can't answer questions using one source, React agents will go to the next source. So the limitations of routers over here, and some people find this a very technical conversation, but I want to focus on the technical conversation here, is because we teach technical stuff. So the technical stuff over here is that routers struggle with bidirectional. So they do not have a feedback loop. They do not understand what's happening behind the scenes. So what they do is that they'll just go in one direction. They'll take you to a place where you are able to answer a question, and you basically build a system that sort of generates a response. Now, some of you might be like, oh, so it's a 50-50, right? No, it's not a 50-50. You build a fallback system, or you build better few shot prompting to build an example. That's sort of, so you basically do better prompting, you build a fallback, and most importantly, you do evaluations. To your question, it's you're saying it's totally at the mercy of the system prompt and LLM to decide. Yes, it is. But what you can do is you can build an evaluation to see what kind of context engineering can be done to improve this. And that is something that we have seen over time that plays a major role. Evaluation is the driver to you building tools that work. And this is the first step to evaluation. Like, I could have shown you code that just worked beautifully. You would have been like, this code always work in every use case. But you saw in semantic search, I showed you the good part and the bad part. Here I'm showing you the good part, and I'm also showing you the bad part. I've chosen examples almost in a 50-50 way, that things that work and things that don't work. However, there is a systematic way of reducing this. You use evaluation to see what's not working, and you use prompting and future prompting methods and a fallback method, so that you can save yourself and actually use these things to build them better and design them better, so that every time we have these challenges, you're able to get to the answer correctly. That's where React based tools sort of play an important role. And that's why we teach React as the second part of our tools, is that React basically gets you to that answer based on that response, right? So just to recap on what I just showed you over here is, RAG is great. You guys have used it. Naive RAG has a lot of challenges. We made them clear. One of the ways to solve that is to build a router-based system. The goodness of your router-based system relies entirely on how good your prompt for the router is. So the point that I'm trying to drive home is, it's not all blue and green and amazing. It's work, it's effort that requires, and there are always positives and negatives on how you build products. My job is to expose them to you all, so that when you look at these things, you're like, oh, these are the challenges when I build something like this. These are the challenges because there's no such thing as perfect recipe. But you can reduce these challenges by grounding your responses. You can reduce these challenges by building better prompts. You can improve these by sort of building an evaluation data sets that can help you answer these questions based on that. AGR77, you said, if we have logical separation, how do we identify to which subset to move into? The way you want to do that in order to build that is you basically do evaluation data set, and you basically test how did your LLM route or how did your router work in the first place. We do not have evaluation. We have very little actually evaluation covered in the next class. I usually teach that teach that in my other courses, but there is like, at least now you know there's evaluation. You need to start thinking about, it's like, if you are a machine learning engineer and you build a model and it predicts something for you, you can only know how the prediction works if you were able to evaluate the answer. Similarly, when you want to build better tools, you have to evaluate those tools. And evaluation basically is the concept which is becoming more and more important, because if you just build a tool, like I could have shown you every single answer that worked over here really well, and you'll be like, well, it's perfect. I'm going to go raise a bunch of money. I'm going to raise, $10 million to make my startup. But when you go to your customer and you actually run this in real time, this is where problems will happen. So when you design these things, it's the work that goes behind the scenes, and there are this is dedicated work which is being done behind the scenes, where you sort of design these tools and make them better. One of the articles that I've written is, I think, actually, I have written an article on this. I'm going to go ahead and share that article with you all so that you guys can check it out. Let me see where that article is. Okay. So this is the article. Sorry, let me just open it. So this is the article that I recently wrote about how to build evaluation. So what I will do is that I'm going to put this in the chat. And what I would really appreciate if you guys can follow this, leave a comment, like it or something. This is what I've written in a very in-depth way of how do we evaluate LLMs. These are some of the benchmarks which can be used. How do we evaluate reasoning models? This is an entire benchmark for that. Then how do we do evaluation for retrieval? There are different concepts over there. Then how do we evaluate our RAG, the end-to-end system check, which has faithfulness, grounding, answer relevance. And finally, we have basically evaluation for agent. Like, what was the task? What was the efficiency? This is where you basically you start looking into the agentic router evaluation. So if you don't follow me on Substack, I put a lot of I write a lot of articles on Substack with my team. So follow through this. Again, listen, all we have built this for free. We just want you to be able to read this. What I see happening in the industry, which is sort of like a big concern for me, is that we're building tools that do not we're unable to understand, or we are using tools that we don't understand. But we want to build tools that we understand and we're able to design and fix them ourselves. What we don't know in LangChain and Llama Index a lot of times is that what is broken in the first place. I want you all, or this is my desire. This is my biggest desire, is that you all are able to use that, building that. There is a comment from someone. Remember, all that article are AI generated using n8n. Uh, it's actually not true. I do use AI to rewrite my articles, but at the end of the day, you have to do the research yourself to build them. But what I would like to say is, I use AI and LLMs every day to build articles. I use, but it's basically, think of it, 80% work for me. Sometimes it's 20% work, because you have to put together the idea on what you want behind the scenes to do that. So there's no shame in using AI. The shame is that if it's not valuable to you or not. So here in my code, what I'm trying to show you all is all AI, right? This is all AI. But what I'm trying to show you, the good and the bad of these things, what works and what doesn't work. And that's what's most important. What I feel for you all is, you should understand what runs behind the scenes, or you run behind the scenes, and you sort of build your understanding on that. Like, what is the good and what is the bad? Like, you all have used AI, it sometimes does a great job for you, sometimes it's just crappy, right? How do you improve that? That's the idea. All right. So what we are almost at the end of our today's session. What we would love for you to do is join our next session. We're going to talk about React framework, reason and act in motion, and then on day 4 we're going to talk about GCP, ADK. These are all code heavy. However, we have a lot of content also to cover on them. The reason we keep them, we share code, or we basically show you live code, is so that you can evaluate those things. Uh, 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 you should be able to use it and build on that. So I would really like you to sort of come in, join, look at these coding, and over the week, what we'll do is that we'll be sharing all the notebook, all the code that we have shared. In React, we'll talk about discover the React paradigm, how it works, how agents analyze context, built-in agents that adapts intelligently. So we will basically go from what router could not do to building React. And I'll also talk about things that does not work over there. The idea is, we want to be able to build those things, and know what works and what doesn't work. I mean, there's no one perfect solution to everything. And then finally, in module 4, we'll talk about GCP and all those things. One thing is I would really want to highlight is, we're offering 2 scholarships for this course. This is the course we have. We are very, very proud to be on one of the highest rated scores on Maven. um, so again, all you need to do, literally all you need to do, is post about this course, use LinkedIn, use Twitter, whatever you want to use. Post about this course. If you post about this course, what we will do is that, we would love for you to post about it, and then tell us that you've posted about it, or tag us. And what we'll do from there is that we will pick you, will offer you scholarship for these programs. And if you think that we don't offer, if you think we don't give scholarships, there half of my company was on scholarship on my courses, who ended up working for us. So we have, I know there are a few people over here. PM stands for product managers, and prime minister, both at the same time. We have, Amna, if you can just message over here. So there are people who have taken scholarship. There's Osama, I think, who he was on the call. There's Amna, who's on the call. There, I think we have given 20 scholarships scholarships over in the past. Basically, these scholarships give people an opportunity to learn with us. Again, all we ask you to do is share on LinkedIn about what we're doing, about our course, and that's it. We would love more people to join in. We would love more people to sort of share their learnings with us. And what I have to share, I want to bring it to everyone. So all you need to do is write and post, set it to public, tag me, tag and Gabriella. If you once you do that, what you can do is you can scan this QR code and you can submit. We'll send you this in the following up invite. And so scan this code, use this code to sort of submit to us that you basically use that. Guys, this is the best we can do. We are doing live courses. We have more bigger courses. We have bigger courses that we teach. They are smaller cohorts, and we focus on very good personalized learning. I think we have Ben from here who has taken a course. We have other people also who have taken the course. I saw Ben. Um, but check out our courses, check out what we offer. And with that, thank you everyone. This has been a great session. This has been great interaction with you all. What I would love to do is we'll keep sending you stuff. We'll we're figuring out how to send more emails to you without spamming you. So the best thing would be that if you follow us on Substack would be one of the best ways to sort of connect with us. We post a lot of things over here. So if you're on Substack, if you're not on Substack, get on Substack. Honestly, I have written a ton of articles over here. I previously used to put all my articles over here. They're still here. They're all free. None of them needs to be paid for. All I'm asking you guys is to be willing to learn. So this is the link to my Substack. I think you should be able to use this, right? And if you're not doing that, then it's on you. Honestly, it's on you after that. But if there are a lot of sources available, most often the biggest challenge people have is, where do I get started? This is where you get started. This is what you need to do. You need to get in, learn, build these things, look at what works and what doesn't work, ask the right questions. If you ask the right questions, you will find responses, you will find the right answers on what's working and what's not working. All right, so we are at time. Thank you everyone. Thank you everyone for joining in. Share this with your network so that we can increase, we can reach out to more people. And with that, thank you everyone, and I will see you all next week. Until then, take care. Goodbye. Thank you.